All right, we're going to do questions involving Pascal's triangle. So before I start the homework and everything, I just want you to take out a blank piece of paper with me. And we're going to recreate it like lots of rows so you obviously see the pattern. So whenever we start it, it's like a Christmas tree. We start with 1 and we end with 1. So the beginning has 1, start with 1, end with 1, start with 1, add, and then end with 1. And I want you to keep working on that pattern. We start with 1, we add 2 numbers, we add the next numbers, end with 1. Start with 1, we add the numbers, end with 1. And I want you to feel comfortable with this pattern going across. I'm going to do a few of these. So I want to know, press pause. I want to see if you can do the next row before I do it. All right, let's see if you did it right. And there's obviously symmetry here, right? In terms of what's happening to the left and right. I'm going to try the next row, press pause. All right, one more row and then we'll stop. 9. Can you do the next row and then we'll stop? See if I can add this up. 70 and 14, that's 126, and then it should be the same numbers going back the other way. Oops. 2 126. That's 126, that's 126, this is 84, 36, 9, and 1. These are both 126. All right, next, I'm going to expand this just a little. I want you to put a row and make rows for each one on your page. And then recognize the top 2 are not very interesting, but the next ones in terms of the exponent 2. I want you to recognize this is the number that correlates to the exponent that we're going to use. So if it's raised to the exponent 2, the second number is 2, that's one we use. Is it raised to is a binomial raised to exponent 3? It's the second number. So this one here tells me in terms of which row I'm going to use. All right, now let's go to our homework and just practice a few. We're going to do more in class next time. All right, so the homework was number 1, number 2, I think number 5. Where's the 4? 1, 2, and 4. 1, 2, and 5. Let me double check. So 1, 2, and 4. Okay, so step number 1 is to identify the 2 terms. That's x and negative y. And then we go to the correct row. So if I'm raising it to the exponent 8, you know what we did before. The second number is 8. That's the row we use, and we're going to use these numbers. That's a lot of numbers. So we have 1, and then we have x and negative y. The biggest number is 8, and the smallest one is 0, and we follow that pattern going across. So the next number after 1 is 8, and now it's 7 and 1. Keep going across. 28. That is 6 and 2. The good news is there's not numbers to multiply because it's just x and y, so it'll be easy to simplify. The next one's 56. Again, I'm following the line 8, 28, 56, 70, and so on. So 56, and then the exponent goes down, and the next exponent goes up. It will always add to 8 what the exponent was. 70. These are both 4. 56. Now it's going to go, this is going to go to 3, and then this is going to go to 5. Oops, like that. 28. This is 2. And this is 6. 8. This is 1 and 7, and then last one 1. This is 0 and 8. All right, then we simplify this. So anything to the exponent 0 is 1. So this is 1 times 1. That leaves me with x to the 8. There's our first term. Here, just be careful if it's positive or negative. So a negative y to the exponent 1 makes it negative, and it's 8x to the 7, and then y. Next one, that's an even exponent, so it's plus 28, x to the 6th, and y squared. Here, an odd exponent, so it's subtracting 56, x to the 5 and y cubed. 70, even exponent, so it's plus 70, x to the 4, y to the 4. Odd exponent, so we're subtracting to the 3 and to the 5. Here, even exponent, so it's plus. See how it alternates signs? 28, x squared, y to the 6th. Almost there. 8, that's an odd exponent, so we're subtracting. Then 8. Notice I don't have to put a 1 with the x, just x and y to the 7. And then the last one, this is x to the 0 is 1, so it just leaves me with this even exponent with negative y. So that means plus y to the exponent 8. And there it is. Using Pascal, you can't imagine if you didn't have a calculator how long that would take, right, to expand if you didn't have Pascal's triangle. All right, let's try number 2. So it's to the exponent 5. So the Pascal's triangle, we're looking for the second number is 5. So this is the row we're going to use. So this tells me the number to start with, and then we follow the pattern. So the number I'm going to start with 1, and then I have 2k and negative 3. This one starts with the largest exponent and the smallest one, and then we build the pattern from there. So after 1 is 5, that's 2k to the 4, and negative 3 to the 1, 10. That is 2k to the 3, and negative 3 squared. 10 again. 2k2 and negative 3. After that is 5. We're almost done. 2k1 and negative 4. And then 1, 2k0, and negative 3 to the 5. All right, now we got to simplify it. This one will be a little trickier than the one above because you have numbers you need to multiply. So negative 3 to the 0 is 1 and 1, but 2 to the exponent 5 is 32. K to the 5th. Negative 3, and it stays negative, so we're going to subtract. And then 2 to the exponent 4 is 16. And then times 5. I hope I got this. 16 times 5 is 80. And 80 times 3 is 240. So that's where the challenge comes in. All right, 16 times 5. Yeah, is 80 times 3. All right, let's try this one. See if this one's better for my brain. 9. It's going to be plus because the even exponent. 2 cubed is 2 times 2 times 2. That's 8. So 9 times 8 is 72. Times 10 is 720. That makes nice to multiply times 10. Here, an odd exponent with a negative, so there's a negative. 27 times 2 squared, which is 4. So 27 times 4. Let's do that here. 27 times, make sure I know what I'm doing. That's 108 times 10, put a 0 at the end. K cubed. Where are we at? Oh, we just did k cubed. K squared, I mean. So I'm going to knock them out. We got 2 left. Negative 3 to the 4. That's 3 times, that's a plus. 3 times 3 times 3 times 3. That's like 9 times 9 or 81. And then 81 times 2 times 5 times 10. Just put a 0 at the end. So that's 810k. And then negative 3, negative 3, negative 3, negative 3. Well, negative 3 to the 4 was 81. So if I go one more 3, that's 243. So minus 243 at the end. So the challenge really, after the setup, the structure eventually gets really simple, right? To see the pattern. is can you multiply the exponents with whatever number is to get that coefficient? So are you comfortable with exponents and multiplying? Do you have to multiply it out? Take your time. That's going to be the challenge. All right, last one, super fast. The ninth row is saying the ninth when the second number is 9. That's why I made you go to 9. And then the sixth element means count over 6. What's the number? So from here, 1, 2, 3, 4, 5, 6. The element number is 126. And we're going to practice more. But I just want you to do a few of them just to get a sense of the pattern and structure and be comfortable multiplying with exponents and other numbers if it's adding or subtracting. So I'm proud of you for doing your work. Mr. GMath over and out, and I'll see you next time.